Hello, good afternoon, everyone. I hope everyone has had a good week so far. Probably lots of exercise from shoveling the snow, but it's time for more biology. We are going to be doing lecture 2 today, which is macromolecules, and there are a lot of things to go through. So let's get started. Macromolecules. What are macromolecules? Well, the word macro means really big, right? So these are just basically really big molecules. So if you think of something like water, right? So water is H2O. It has 3 atoms. So that's quite small. When we're talking about macromolecules, we are talking about like thousands and thousands of atoms. So much bigger. So let's start with some basic chemistry. List 5 major elements found in living things. So of course, our body has a lot of different elements, different types of atoms in it, but it turns out there are 5 key ones that are in particular high percentage. Okay, so in no particular order, these major elements include carbon. We're looking for elements. So elements would be things that are on the periodic table. So carbon, right? Carbon is one of them, right? That would be C. That's the symbol for carbon.
Oxygen?
Yeah, oxygen is another one. Calcium is not one of the major ones. It's one of the trace ones. So we'll get to it in a second.
Nitrogen?
Hydrogen is correct. Nitrogen. And one more, which is phosphorus. Okay. So these make up the majority of the molecules in the body. And then we have the trace elements. Trace element. Can someone tell me what is the meaning of trace element?
Because our body cannot make it, we need it.
Not so much we cannot make it.
They're in a smaller amount. They're not as major as the other ones.
Exactly right. So trace elements are elements that are required in small quantity. Okay, and it's actually true as well that we cannot make it ourselves. So we would be consuming it from our diet. Okay, sorry, I spelled quantity wrong.
Sir, I'm not gonna lie to you. Part 3 of the lecture, it kind of lost me there. I had a little hard time understanding.
Yeah, we will hopefully address some of your concerns, and if not, please do ask questions. Sayida says sulfur. Sulfur is not a major element. It's found in proteins in small quantity, but it's nowhere near as abundant as some of these things. Okay, so I believe Sayida was asking about the 5 major elements. Now we're talking about trace elements. So often these elements, if you have too much of it, it's going to lead to some kind of toxicity. And if you don't have enough of them, you are also going to have some kind of a deficiency as well. So some people have already mentioned some examples of trace elements. So I'll just write them down. So someone says zinc. That's important for your defense system. Iodine. Okay, that's important for your thyroid gland, which is right here. The thyroid gland makes 2 hormones called T3 and T4, and they use iodine as raw material. Those hormones are important for regulating your metabolism. Okay. Another one is calcium. Very good. Yeah, feel free to just type the answer in the chat box. Okay, as I do this, I will try to keep an eye on both screens. And then one more, It really could be a lot of things. Okay, I'm just going to put magnesium. Okay, magnesium, Mg. Okay, it's important to know that when we write down these trace elements, we are not talking about them existing in their elemental form. Okay, when I say you have calcium in the body, it's not the pure calcium. Yeah, you might or might not know that pure calcium actually will explode in the presence of water. Okay, literally blow up. You can search it up on YouTube to get a video to see how it looks like. So when we talk about calcium, we're talking about its ion form. So like calcium +2, for example. Okay, it's going to be existing in the form of a compound with something else. Same thing for the zinc, iodine, and so on and so forth. So it's not its elemental form, not its pure form. It's going to be in some kind of compound. All right. So speaking of compounds, which is something that you would get when you put elements together. Okay? When you take atoms from different elements and you combine them chemically, you can either get an ionic compound or a molecular compound. Okay, so let's compare these two things. In ionic compound, we have metal plus non-metal. Okay, so in the lecture notes, I don't have a periodic table handy with me right now, but in the lecture notes, this is what a typical periodic table looks like. There's a ladder that kind of goes down here, and everything to the left of that is typically considered as metal, and here is the non-metal. Oops, non-metal. And sorry, it's a little bit crowded there. So if you take something that is in the metal area and then you chemically combine it with a non-metal, that's how we get ionic compound. Okay, and the type of bond that you form as a result of this is an ionic bond, which is easy to remember because it's same as the compound name, right? So in an ionic bond, we have a transfer of electron. Transfer of electron or electrons, could be more than one, from the metal to the non-metal. Okay, so you probably will, either you've learned it already or you will be learning it in chemistry class soon, that metals, right, these guys on the left side of the periodic table, they don't really like electrons all that much. They rather give it away. Okay, they're more stable that way. Whereas non-metals, they are more stable when they receive electrons. Okay, so they are perfect for each other. Metals will want to get rid of electrons. Non-metals would want to pick them up. So when you transfer the electron from the metal to the non-metal, you form an ionic bond. Okay, ionic bond. So ionic bond is quite strong. It holds the metal and the non-metal together. And typically speaking, the ionic compounds, they would be solid at room temperature. Okay. Can anybody give me some examples of ionic compound? You can type it in the chat. You can unmute.
Salt.
Yeah, okay. What kind of salt? Do you have a actual formula?
Sodium chloride.
Sodium chloride, that's correct, right? So NaCl, right? Salt is a general term. In fact, ionic compounds are generally called salt, right? We have different types of salt, right? We have table salt, which is what this is. This is the stuff you put on your fries. The salt that you put on the driveway, that is another type of salt, right? You know, in general, these are called salt. Tristan has another one. Okay, magnesium hydroxide. Sure. Okay, that's a fancy one. Okay, so all these are examples of ionic compound. The key thing is there is a metal and there is a non-metal, and it involves a transfer of electron to form the bond. Next, we are going to have molecular compound. Molecular compound. In molecular compound, we will have non-metal plus non-metal. It could be two different types, could be three types, right? It's just made up of a bunch of non-metal atoms. And instead of forming an ionic bond, we have what's called a covalent bond. Covalent bond. Okay. So the covalent bond is, rather than transfer of electron, it is going to be sharing of electron. Sharing of electrons between the nonmetals. Okay, so not a handover of the electron, but they share it together. Molecular compounds can exist as solid, liquid, or even gas at room temperature. Okay. Examples. Anybody want to give me some examples? Maybe one solid, one liquid, one gas. Anybody?
H2O.
H2O. Yeah, H2O is liquid. That is water, of course. How about a solid? Anybody know a solid molecular compound? Gold is an element, so it's not a compound, not a molecular compound or ionic compound. A good try though. Yeah, CO2 for gas from Clara. Sorry, Sierra rather. That is carbon dioxide. And Christina said sugar. Sugar is solid. So C6H12O6, for example, that is glucose, and that is solid. Okay, platinum is an element, so that is not a compound. All right. Yeah, carbon monoxide also works. Very good. Any question before I move on? Okay, I hope this pace is okay. If I'm going too fast, then let me know. Okay, if I'm going too slow, too bad. Some students were telling me last semester that they have to watch my lecture recording at 1.5 times speed on YouTube because I was talking too slow. I always thought I already talked pretty fast, but you know, to each their own. Anyways, Saida asked, do we have a quiz? Yes, we have a quiz next week, but I'll talk more about it later. Okay, because people are still trickling in. I'll mention, tell you more about the quiz. Yeah, I know. I actually talk fast. People tell me that a lot of times, so I'll try to slow down. Next one. Indicate the polarity of water molecule. What is polarity? Well, basically, in very simple sense, polarity is, you know, you are asking yourself, are electrons being distributed evenly in the molecule? Okay. So if the answer is yes, they are being distributed evenly, then we say it is non-polar. If the answer is no, right? No, they are not being distributed evenly, then it's going to be polar because you will have electron hanging around on one side more so than the other. So that makes it polar. Okay, so water molecule this is how you draw it. If you don't know about this yet, you will be learning it in chemistry class. So we have 1 oxygen, 2 oxygen, and here this is your covalent bond, right? Covalent bond. It represents 2 electrons being shared. Okay, but here's the thing. Even though we are saying that they're sharing the electrons might not be shared equally between the two. Okay, yeah, that is a single bond, just one line. Okay, so it turns out oxygen has a higher attraction for electrons, so it's going to be pulling the electron towards itself. Okay, so even though they're sharing, but the electron actually gets pulled towards the oxygen a little bit more. So for that reason, the oxygen will be slightly negative, and we use this squiggly symbol, right, the delta symbol, to represent slightly. So slightly negative for the oxygen and slightly positive for the hydrogen. Okay, so water molecule is polar because of uneven sharing of electrons, causing one side to be more negative and then other side to be more positive. Is that okay? Now, it's important to note that even though the water molecule is polar, right, the overall molecule is still neutral. Okay, it's not like there are extra electrons or missing electrons. It's just that the electrons are being pulled towards one side of the molecule compared to the other. Okay, so if I had to describe water molecule, I would say it is neutral but polar. Okay, one doesn't really have anything to do with the other. They're two separate concepts. All right. So what? So what if water molecule is polar? Well, let's draw two water molecules together. Okay, so there is a water molecule. You can draw them using these space fill model. There, that's what they're called. Right? Looks like Mickey Mouse. We have the hydrogen here, and then we have the oxygen here. Okay, so because of what I told you, you will know that the hydrogen is slightly positive and the oxygen is slightly negative. So if I have another water molecule, another Mickey Mouse here, right? The slightly negative portion of oxygen will be attracted to the slightly positive portion of another water molecule. Okay, so like that. And I can draw another one if I want. And I want to do that. There is hydrogen, hydrogen, right? So there is an other attraction, right? And then there might be some interaction here. So all these interactions between different water molecules, we call them hydrogen bond. Okay, hydrogen bond. So there are other molecules that can form hydrogen bonds. I don't want to go into too much of the chemistry, but this would be one example of an hydrogen bond. Okay, so because of hydrogen bonds, it allows water molecule to kind of cling on to each other, right? That's why you can drink liquid with a straw, right? So if you have a straw, right, and then you suck the water up, right, you will see that the water kind of clings onto the side of the straw like that, right? So that is because of this property, right? These cohesion interaction. All right. Moving on. Using a diagram to explain how ionic compounds such as NaCl are soluble in water. So NaCl, as you know, because we wrote it down earlier, this is an ionic compound. So generally speaking, ionic compounds, they are able to dissolve in water. They're soluble in water. And you put salt in water, you stir it up, it's kind of dissolved in it, it's gone. You don't see it anymore. So what exactly is happening? Well, in the ionic compound, the metal portion is the one that is going to be giving off the electron. So it's going to be positive, right? Electrons are negatively charged, right? So if you give away an electron, it will be positively charged. Whereas the chlorine is going to be receiving the electron. So once they receive that extra electron, they become negatively charged. So in the water, you will have the Na plus over here, and you will have the bigger chlorine minus. And what the water molecule will do is the water molecule will come, and because sodium is positively charged, they will orient themselves such that the oxygen will be pointing towards it, right? Remember, the oxygen is slightly negative, right? Negative, 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 negative. So that kind of surrounds the sodium. On the other hand, for the chlorine, because it's negative, the water molecule would rotate so that the hydrogen is now facing the chlorine. Okay, and it's this ability for water to surround the two parts of the salt separately like this that allows it to dissolve in water. Okay, if we have a compound that doesn't have a positive and a negative thing in it, right? Something like, you know, CH3, CH2, 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 CH3, something that has a lot of hydrocarbons in it, right? We call this pentane, which is kind of like a fuel, like propane, butane, that kind of stuff. This is not going to be soluble in water because water is not going to be able to surround it like this. Okay. And so this here, NaCl, is hydrophilic, water-loving. And pentane here is hydrophobic. Okay, because water cannot surround it. You're not going to be able to separate it into a positive and a negative portion. Okay. Any questions so far? All right. Let's keep going. Compare acid and base by completing the table below. Okay, so to keep it very simple, acid is basically a compound, a substance that will produce H plus when dissolved in water. Okay, so you can have some powder, put it in the water, stir it up. If it produces H plus, then we call that an acid. On the other hand, yeah, H plus is a proton. That's right. So you can say produce protons if you want to, you know, call it by its proper name. A base, right, is something that produces OH minus when dissolved in water. Okay. So this here, this has a name. This is called hydroxide. Okay, OH minus. Okay. Someone earlier said MgOH2, right? That is magnesium hydroxide because of the OH. Okay, so if you put this into if you put a base in the water, it will generate OH minus, and it's going to be called a base. pH is a scale that we use to measure the acidity of something. Right? The opposite of acidity is alkalinity. Okay, so if something is acidic or not, we use the pH scale. The scale goes from 0 to 14. It could go beyond 14 in some cases. It can even be negative, but for like usual application range is 0 to 14. If it is less than, if pH is less than 7, then it's going to be acidic. If it's greater than 7, then it's going to be basic. If it's exactly 7, then it's neutral. Okay, so pure water, for example, is neutral. Okay. Next, properties. Acids. Right? If you taste acid, not every acid is safe to consume. I would tell you definitely do not drink your battery acid, but some are safe to consume. Right? Some like orange juice, for example. If you try that, it's going to taste sour. Okay, how does base taste like? Anybody? How does base? Yeah, bitter. That's correct. Okay, if you put a bar of soap in your mouth, right, lick it a little bit, it's going to be bitter. Another property is that it will conduct electricity. Okay, base will also conduct electricity. Okay, so this one, the base also feels like slippery, slimy. Slippery is probably the right word. Like if you rub the soap, right, it feels slippery. Okay, and yeah, let's give it one more for acid, like corrosive. Okay. So
I think slimy was the better, because slippery is an action. I don't know.
Yeah, let's stick with slimy. Yeah, sure. Slippery, slimy. Okay, example. Give me some examples of acid, please, other than orange juice. Anyone else? Vinegar, lemon.
Your stomach acid.
Yeah.
Stomach acid.
Yeah. Vinegar, someone said. Anybody actually know what the stomach acid is?
Bile.
Hydrochloric acid, that's correct. Bile is what your liver makes, and that helps you break down fat. So that's actually not an acid, but good try. So HCl. Okay, base. Banana. Nah, if something is solid, it's hard to tell if it's acid or base, right? Like you can't dissolve a banana in the water and say, oh, does it produce OH? Like that's not everything is acid and base, right? Like, you know what I mean? Egg white, you guys have really interesting examples. Let's stick with the more common ones. Bleach, yes, bleach is one. Soap, right? Ammonium is found in ammonia, sorry. It's found in like cleaning products, right? Stuff like that. Okay, sugar, it's neither acid or base. Again, not everything has to be acid or base, right? There are a lot of stuff that are neither, right? Like, is the pencil acid or base? Neither. It's like, it's not a valid question, right? So not everything has to be one or the other. Anywho, that is that. Okay, that's all the chemistry. Just want to do one more check. Any question before we move on to the bio stuff? This is kind of like biochemistry, you know, a little bit of both. Yes, Sita, I see that you've unmuted. Something you want to say?
I little bit confused about base. That's the
Which part is confusing? This part here?
like a definition.
Definition. Okay, so I'll give you an example, right? Example of an actual base. Okay, we can have like NaOH. That's a base because if you put it in water, it's going to separate into Na plus and OH minus. So if it's produced OH minus when you put it in water, then by definition, it is called a base. Okay. To keep it very simple, if you see a chemical formula and it has OH in it, then we can call it a base. Okay. Someone said magnesium hydroxide, right? That's a base, right? Okay. Anybody heard of like the milk of magnesia or something like that? Anybody heard of that before? No?
No, but when I think of base, I think of a lab that I did. I think it's like the titrate lab where you drop
Oh yeah, the burette, right? When it turns pink, right? That one.
One of the worst labs ever.
Yes, the milk of magnesia, it's basically magnesium hydroxide. It's a thing that you drink when you have an acid burn, okay? Acid reflux. Okay, it neutralizes the HCl.
So Tums?
Yeah, basically. Tums is not the milk of magnesia, though. Tums is calcium carbonate, which is a different kind of base. Someone said, does it make you sleepy? I think you're thinking about like you see on TV. Some people say like milk of the poppy. That's the one that makes you sleepy. Okay, that's basically morphine, painkiller, makes you sleepy as well. Okay, Jory looked up banana because I said banana is like, you know, can't really say acidic or basic, but he looked it up and it says the banana has a pH of 5, apparently making it acidic. Interesting, did not know that. Yes, but I guess it depends on the ripeness as well, right? If it ripes, if you eat green bananas, it's a little bit sour and, you know, got a tartness to it. But if it's really ripe, maybe the pH change a little bit. Saida said, I mentioned in the tutorial recording that blood is slightly basic. Yes, that is true. Blood is 7.35 approximately. You cannot go too high or too low. Okay? You're going to slip into a coma. Not a good thing. If it's too acidic, we have acidosis. Okay, acidosis. And that is not good. And if it's too basic, we have alkalosis. Also not good. Okay, so we have buffers in our body to keep it at 7.35. Okay, moving on. List the 4 types of macromolecules found in the body. In no particular order, we have carbohydrates. Right? People call them like carbs. You gotta, you know, eat carbs. You gotta cut down on carbs. Carbs only, less carbs. Lots of different theories about whether you should have carbs or not in your diet if you want to, you know, lose weight or gain weight or whatnot. Proteins, that's another one. Nucleic acid. And the last one is, no one mentioned this one yet, lipids. That's right. Thank you, Hans. Lipids. Okay, so the protein, the carbohydrates, the nucleic acids, these are polymers. Polymers of repeating units. Okay, not so much lipids. Lipids are kind of like its own thing. It's more like components rather than, repeating units. Now, I do want to clarify that these are not the only polymers that exist, in the world. Okay, these are just the ones that exist inside a living system. We have a lot of polymers in our daily lives. Anybody have an example of a polymer that is in your house? The question is, does anybody have an example of a polymers that that is in our everyday lives? Okay. Maybe at your home, you have polymers at your home for sure, definitely. Anybody have an example? No. That's okay. So plastic, for example, plastic is a polymer, right? Okay. Your clothing, polyester, right? That's a polymer. If you cook your non-stick pan, the Teflon, that is a polymer. Okay, so polymer basically just means a bunch of repeating units connected together. Okay, so that is the definition of a polymer. So these individual units that we are connecting them together, those units, they are called monomers. Yeah, so DNA is a polymer, and it's an example of nucleic acid. Okay, very good. So here in this diagram, on the left side, we have all these individual units that are not connected. So those would be the monomers. Monomers. And over here, they're all linked together. Okay, these are polymers. So in order to connect your monomers together to make the polymers, we are going to do a type of chemical reaction called dehydration. Dehydration synthesis. Okay, and it's also okay to call them condensation reaction. Okay, so in the chemical reaction here, what you're going to do is you're going to remove a water molecule between two monomers, and you're going to connect them together. Okay, and this bond that you create, the bond that connects the monomers together, that is always going to be a covalent bond. Covalent bond. Okay, no ionic bonds for polymers. All these linkage, they're covalent bond, which means it involves a sharing of electron. So when you want to break the polymers, so let's say you eat some starch, right? Starch is an example of carbohydrates. If you eat them and you want to break it down to extract the energy from it, you will be converting the polymers back into the monomers. And the process to do that is called hydrolysis. Hydrolysis. Okay, hydro is water, lysis is to break. So you will break the polymer by adding a water to it. Okay, break the bond by addition of H2O. Okay, so forming polymer, dehydration synthesis. Breaking polymer, hydrolysis. Okay. Moving on. Carbohydrates. Carbohydrate. Complete the chart about carbohydrates. So what's going on here? The elements contained. Right? What are carbohydrates made up of? They are really big, but it's just made up of three elements. There's the carbon, hydrogen, and oxygen. Okay. In fact, the name carbohydrates, it means the general formula is CnH2ON. It means for every unit of carbon, you will have the same number of hydrates, the same number of water. So if N is 6, then we have C6, H12, because 6 times 2 is 12, O6, and you would get like glucose, for example. So what are the building blocks of carbohydrates? What are the monomers that we use to make really, really big carbohydrates? There are 3 that we talked about in class. Does anybody remember what they are? No? Yep. Glucose is correct. And then what's the other? Sorry, I didn't catch what you said.
Fructose.
Fructose, yeah.
Yes.
And then one more.
Maybe sucrose.
Sucrose is it's something that you get when you put 2 monomers together, but good try. One more, yeah. Christina said galactose in the chat. That is correct. Okay, so you guys should know what these are. Okay, because I could easily ask you a question. Identify all the which of the following is a monomer, then you should know. Which of the following is a monosaccharide, then you should know. Okay, so these are single sugar, which is why we call them monosaccharide. Mono means single. Saccharide means sugar. Single sugar. Okay, so there's 3 of these. Okay, and I should also mention that these are isomers of each other. Isomer of each other. Okay. What is an isomer? Isomer means, okay, that is same number, same type of atoms, but different arrangements. Okay, it's like having a box of Lego. You can build a house, you can build a car, you can build a boat, whatever. All 3 of them have the same Lego pieces, but it's arranged differently. Okay, so when that happens in molecules in chemistry, we call them isomers. Okay, so all these are C6H12O6. They all have 6 carbons, 12 hydrogen, 6 oxygen, but they are rearranged. They are arranged differently. Okay, so these are the building blocks. What do we use carbohydrates for? Well, we use it for things like energy, right? Main source of energy.
Sorry, I interview. Does isomer and isotopes is similar?
Yeah, okay, so isomer is like this. Okay, let me give you a concrete example. Let's say we have C, 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 C. Okay, so I can draw it out like this. Okay, so this is a molecule, right? Okay, never mind what it is called. Okay, so if we count, we have 4 carbons, 1, 2, 3, 4, and then we have 10 hydrogen, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's one molecule. Now I'm gonna draw something that looks different. I will not ask you to draw anything, okay, guys? Don't worry if you don't know what I'm drawing. I'm just trying to show you. Okay, this is also 4 carbon, 10 hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you see, these 2 are isomers because they have the same formula, but the shape is different. The arrangement is different. Okay. You mentioned isotope. Isotopes. Okay, what are isotopes? Let's say I have carbon 12 and carbon 13. Okay. Both of them are carbon. Both of them have 6 protons, but this one is heavier. Okay, so isotopes are atoms of the same element that has different number of neutrons. Okay, so these are different concepts. Okay. Biological function, main source of energy, structural support, right? For plants, for example. Also, we need it for storage of energy. You can burn it for energy immediately, or you can store it. Right? These are some examples of biological functions. of carbohydrates. Okay, so let's take a look at how do we link them together. We have two glucose molecules here. Again, I will not ask you to recognize them. I'm not gonna show you a bunch of these pictures and ask you which one is glucose. That's not fair. I'm not gonna ask you that. But what's important to know is how do we link them together? So we have a glucose here and a glucose here, and to connect them, we will have to do dehydration synthesis, which means we will be removing a water molecule from it. Okay, so we will take an OH here, and then we will take an H here, okay, and then we will connect the C to this O. Okay, when you do that, you will form a new bond. Okay, this is a new covalent bond. Okay, it has a name, but who cares? It's going to look like this. Okay, so you're gonna have a new bond. I'm not gonna draw everything else. I'm just gonna keep the hexagon. And now I have a disaccharide. Okay, two sugar connected together. Okay, of course, plus water. Where did the water come from? Well, I removed it, right? H here, OH here, and that removes the water molecule. Does that make sense? And you can keep on doing this. I can have another glucose and now remove the OH here, remove an H from the next one and keep on linking it, right? So then the disaccharide will grow with a third sugar, fourth sugar. Eventually it becomes very long. Then we call it a polysaccharide. Okay, a sugar that's very, very long. All right, let's try a question here. Sorry, I'm just trying to position it. Okay, go ahead. If you're not sure, please choose E. So that way I know you're there.
Sir?
Mm-hmm.
Oh, okay. We did that yesterday or no?
Yesterday?
Yes. Or no?
We didn't have class yesterday though.
Or
Wait, what? Were you? Are you in my other session? This is for 201. I mean, yesterday would be the 202. So if you already attended, yeah, if you attended 202 yesterday, you don't have to attend this one. It's a repeat of yesterday's class. Okay, this is only for section 201. Yep, we lost that student. Okay. Anyway, let's see. It's okay if you chose the wrong one. I would not know which one is your choice. Here we go. Okay. Now this question, you look at it and like, what is this question? Like, it's not even anything that we've talked about, right? Like you might feel that way, but you think about it, it actually is exactly what we just talked about. Never mind this hexagon. Like if you don't know what this hexagon means, doesn't matter. And if you don't know what this pentagon means, also doesn't matter. What matters is you remember, if you have two monomers and you want to link them together, I have to remove a water molecule. So you're going to remove an OH from one, you're going to remove an H from the other, and then you will connect them together. Okay. So there is only one here that makes sense, which is B. You got your hexagon. You're going to connect to the O, which is this O, and then you have your pentagon. right? So the correct answer is B, okay? It's not C because C is like 2 pentagons, right? I'm trying to connect the hexagon with the pentagon, right? It's not 2 hexagons, right? For the same reason. And it's not the first one because this is missing an O, right? So the O in between, like this O, is actually that O. Okay? Does it make sense? Would you be able to do this type of question if you see it on the quiz? Or you have a follow-up question? All right, if you change your mind and you want to ask later, you can do that. Okay, we'll come back to this polling stuff later. Let's keep going. Next one, complete the reaction. Okay, so now we have a bunch of stuff here. These are disaccharides, okay? Disaccharide. Double sugar, okay? 2 monomers linked together. Let me write it down for you. 2 monomers linked together. Okay, so how do we form maltose? Sebastian asks, is the quiz all multiple choice? Yes, yes, all multiple choice. Okay, some have more than 1 correct answers. Maltose, what forms maltose? Well, maltose is glucose. They all have 1 glucose. Okay, so let's write that down first. Okay. To get maltose, it would be glucose plus another glucose. Okay. If you read the back of a candy bar, you will likely find maltose. You will probably also find sucrose. Okay. Sucrose is glucose plus fructose. And then lactose, which is like a dairy product, would be glucose plus galactose. Okay, it's easy to remember because there's lactose. Okay. Okay, so these are monomers. If you link them to get together, you will get the disaccharides. And of course, each one of these would be plus water, plus water, plus water. Okay. Complete the chart about.
Sorry.
Yep.
These 6 all, or these 4 all are monomers.
Yeah, these are all monomers. That's right.
Oh, thank you.
Monomers. Right. Monosaccharide. Single sugar. Okay. The stuff in your kitchen. Anybody know what that is? The regular sugar, right? That you put in your coffee, that you put in to bake for a cake. Or if you just need a pick me up, you shove it in your mouth. What is the kitchen sugar? Anybody know? Yes, that is the sucrose. Okay, the stuff in the kitchen is sucrose. Very good. Okay, complete the chart about polysaccharide. So here we go. Starch. Where can we find starch? Starch, we can find it in plants, for example, right? Plants. Right? Example, in the roots. Okay? So potato, it's full of starch. Potato is a root, right? If you think about like carrot, that's full of starch, right?
Would cassava be one?
Sap.
Cassava, no, cassava.
I don't know what that is. What is that? Is that some kind of plant part, or maybe you can type it in the chat box and then I can do a Google image. Cassava. What is that, guys? Let me see. Now you got me curious. That is a nutty flavor, starchy root vegetable.
Yeah, it's like yam.
Is yummy? Yeah, okay.
Yeah, it's like cassava is like potato too.
Oh yeah? Oh, cool.
Yeah.
I did not know that, but according to Google, yes, it is a root type. Very good. Okay, I learned something new. I'm gonna see if anyone in my family know what it is. Cassava chips are bomb. Okay, I'll take your word for it. Okay, main biological functions. What do they do? Well, it is the storage form of energy, right? So when the plants is like in the winter, not enough sunlight, they cannot do photosynthesis and whatnot, they would tap into that reserve, right, for energy. We of course can eat those starchy parts of the plant, and we would get the energy from it. Next one, glycogen. What is glycogen? Glycogen is we will find it in like muscle, right? Muscle and liver, right, of animals. And it's the storage form of energy for humans. Right? I should say the first one is storage form of energy in plants. And this one would be storage form of energy in animals. All right, so if you skip lunch or breakfast today, if you haven't eaten today, I should say, okay, then your body would be breaking down the glycogen reserve and release the glucose so that your body can keep going. Cellulose. Cellulose are found in plants. Okay, they can also be found in things like fungus. Okay, it's not just plants, and they are there to provide structural support. Provide structural support. Okay, so e.g. the fibers, right? The cell wall. Right? So if you think about like a plant cell, which is usually more rigid in shape, right? There's the nucleus in the middle. Outside of the regular cell membrane, you're gonna have an extra wall. Okay, so that is a cell wall, which protects it, gives it rigidity. It's not going to burst easily. And that stuff is made up of cellulose. We, of course, as humans, we cannot digest cellulose. So when you eat a lot of fibers, it just helps your digestive tract move, right? Okay, so some people don't have a lot of dietary fibers. Have you guys heard of like Metamucin? There's the commercial with these happy people sliding down the slide, right? After they eat a buffet or something. I don't know if you ever saw the commercial. Right? It's basically a drink that has a lot of fibers, right? It helps you move your digestive tracts, okay? If you don't have a lot of dietary fibers, okay? So that is cellulose. Yeah, it's not really laxative. Laxative like makes you basically have diarrhea in a sense. That one it's more like a rich fiber thing that moves your tract. Right? It's not gonna make you sick to have diarrhea, but it's gonna increase your bowel movement. They say. I never tried it, but that commercial looks funny because you have all these people pretending to be food going down slides and all happy and stuff. Is there nutrients found in fibers? Yeah, so if you eat like 100% fiber, you will get 0 calories from it, right? Because you are not going to be able to metabolize the fibers. You're not going to be able to harness the energy from it. So that's why people say quinoa is a healthy grain, right? Because you will have the carbs on the inside, but then the shell, which is very rich in fiber, you don't really break that down. So it's a slow releasing carb. Okay, and that way you get your dietary fiber, and then it would help you feel energized for longer because then you will release the energy kind of slowly, right, after you have the meal. I don't know if that answers your questions. Chitin. Okay, chitin is found in. Let me choose my happy orange color here. It's found in like exoskeleton of insects, right? And also crustacean, right? These are like shellfish, right? Lobster, shrimp. Their shell is hard, and it's made up of chitin. You might know some people who take like those glucosamine pills, right? That's supposed to strengthen your joints. If you look at the bottle, sometimes they will tell you the source of those glucosamine is actually from shells of these crustaceans. Okay, so what do? They provide support and protection. All right. All right, let's do some poll questions. Here's another one. This is a multi-select question. Go ahead. Okay, I'm going to give it another half a minute, perhaps. Okay. Here are the results. Let's see. We are selecting all the false statements. First one, polysaccharides are important both for energy storage and to provide structural support. Yeah, that's correct, right? Energy storage would be things like glycogen and starch, right? And support would be like cellulose and chitin. Okay, so that's the correct one, not what we're looking for. We're looking for a false one. Next one, glycogen is important for both energy storage and to provide structure for cell. That is not correct, right? Structure is the chitin and the cellulose, so that is incorrect. That's what we are looking for. Cellulose is only found in animal, not true. It's found in plants and fungus. Glucose, fructose, and galactose are examples of monosaccharides. We know that is true, right? I labeled it for you earlier. And finally, starch is storage form of polysaccharide made by plants. That is also correct. So the incorrect statements are B and C. Okay.
That it's C, it's also found in plants, right?
Yeah, but not in animal. The key here is not in animal.
Oh, okay.
All right, let's try another one. Sorry, someone else? Is someone to comment?
Why was B false again?
B, because glycogen does not provide support, provide structure for cells, right?
Okay, cool. Thank you.
Yeah. All right, this one, I hope everybody gets it right. Okay. Oops. Go ahead. All right, very good. I'm gonna end the poll. Most of you got, like 90% of you got it right. It is the glucose plus the fructose. Okay, that gives you sucrose. All right. Some people chose B, but 2 glucose molecule, that gives you maltose. All right. So like I said, right, it's good that you would be able to memorize this, but if you find it really hard to memorize it, then put it on your help sheet for the test, okay? It's okay to have a help sheet when you do the quiz, okay? But just don't put everything on it because you won't have time to find it, right? It's just the stuff that you really have trouble memorizing, put it on the help sheet, okay? All right, where was I? This is, okay. let's go back to here. I think I'm gonna skip the break today, okay? Because yesterday I ran out of time for my other class. So you know, we're just gonna push on, soldier through this. And if you really need a break, then you know, just come back later, and then you can watch the part that you missed. All right, next one, lipids. Okay, so just a quick reminder. Okay, the lipids is a little bit different than the other types. Okay, so unlike the other three macromolecules, right? So the carbohydrates, the nucleic acid, and the proteins, unlike the other three macromolecules, lipids do not have repeating monomers. Okay, instead, they have components. Okay, so what's the difference between like monomers and components, right? So monomers and the polymers, think of like a train. The train is really long, but each cart is the same, right? Okay, so lipids is not like that. Lipids not like a train. Lipid, it's more like, you know, what's a good analogy to this? Lipids is just like three or four parts come together and that's it. It's not really long. Okay, just a couple parts that you pick, put them together, and then you get like this giant molecule. Okay, rather than a very long chain of repeating monomers. Okay, so let's take a look at some of the common lipids. This is the first type of lipids. Anybody is able to identify what this is? What kind of molecule is this? Anyone?
Triglyceride.
That's right. This is triglyceride, which is a fancy word for good old fat. Okay. So what is the triglyceride made up of? Well, the triglyceride has two major components. Okay. To build a triglyceride, we will need to have this molecule right here. That is called the glycerol. Glycerol. And we will have to have three of these fatty acids, 3 fatty acids. Okay, they don't have to be the same length, but they are fatty acids. Okay, again, you don't have to know how to draw them. You just have to kind of know the components. Okay, and you're going to connect them through dehydration synthesis. So because there are 3 fatty acids, which means after you connect them, you will have 3 water molecules because you have to form a new bond here, here, and here. So each time you form the new bond, you're going to pop out a water molecule. What do we need fat for? Well, fat, believe it or not, is an excellent storage of energy. Right? This is more for like long term. Right? If you miss lunch today, miss breakfast today, you're going to burn your immediate reserve, which is your glycogen. Okay, glycogen is the stuff that you store in the liver and in the muscle, right? But if you don't eat for like, 16 hours, 18 hours, a day or 2 days, then your body will start to break down the fat. Okay, and when you break down the fat, it will release energy. But it's dangerous.
Question.
Yeah.
Sorry, it's kind of a side note. Like, what if you don't have no more like storage reserve? What would start burning then?
Yeah, so like, you would start breaking, if you don't have enough glycogen reserve, you start breaking down your lipids, and then you start breaking down your proteins. And then by that point, right, if you break down a majority of your proteins and your lipids and you still don't have food, then, you die of starvation, right, basically. I was going to say, what was I going to say? Yes, it's dangerous to burn a lot of fat in a short period of time because metabolizing fat, lipids, right, actually would cause your blood to become acidic. Okay, and if you do it very quickly in a very short amount of time, it could cause you to have acidosis. Okay, in fact, you have something called ketosis. Okay, and that is not a good thing. You might have heard of people have those like ketone diets, right? That's basically what it is. You're trying to burn these lipids from your body, right? And generate these ketones, right? And that's supposed to help you lose weight. Yep.
So what happens to people who do like surgery? Like people, I don't know if you've seen people on like My 600-Pound Life, or nowadays
The
like a lot of
liposuctions,
like people do nowadays even too, like a lot of BBLs or whatever. So what happens when they lose that fat like dramatically? Like does the body
it's different though, right? Like if you physically remove the fat, then it's not being metabolized, right? Then it's just out of your body, right? But if you burn the fat, if your body, when I say burn the fat, I mean metabolize it. Okay, so like you break down.
You actually break it down yourself.
Yeah, then the byproduct is something called ketone, and that could cause your blood pH to drop. Okay. Another thing is, have you guys heard of this like new thing? My parents is like talking about it. It's like if you fast for like 16 hours or something like that.
Yeah.
And then you go for a walk and you go for exercise, you're supposed to lose more weight. They swear by it, right? And the theory, intermittent fasting, exactly, right? And the theory is that, after about 16 hours, then your body switch to like starvation mode, and it starts to burn off the fats, right?
But isn't that bad? Because if your body goes to starvation mode, anything you eat, wouldn't it store it back as fat?
Well, that's what they're not saying to like not eat after that, but then it's optimal to eat after that point, because you would have burned off some of the fats already, right? And then when you just eat, you would just be using it immediately as glucose. Eat moderately, right? Of course, like anything you eat excess, the excess stuff is the stuff that gets converted into fats, right? So someone asked, are keto diet and intermittent fasting unhealthy? Then I don't know if it's healthy or not. People swears by it. Believe it or not, I actually gained like 10 pounds at the beginning of the pandemic, because I was stuck at home by myself with my 2 kids for like half a year at the beginning. My wife has to go to work, right? So all I did is like eat snacks and stuff and get 10 pounds. And then, to lose the weight, I just exercised. I didn't do any like special diet. I didn't, do any intermediate fasting. I just, cut down on the junk food, and then I run like 3 or 4 times a week, and then
But I'm the opposite. I can eat like McDonald's every day and I'm still like 120 pounds. I will never ever gain any weight.
Good for you. That's a good thing, right? You have very good genes. But anyways, the point is everybody has different metabolism. Everybody have different ways of losing weight. I don't know which one works, which is healthy, not healthy. To each their own, right? Whatever works for you, fantastic. Where was I? Sorry, I went on a tangent. No wonder we run out of time, but that's okay. It was a fun discussion. Storage of energy. We also need the fat to insulate, and protect organs. Okay, insulate and protect organs. Right? It's like -33 outside. We go outside, our hearts, our kidneys, right, our livers, they're not gonna freeze because of the little bit of fat around it, which is going to be able to keep them safe, keep them warm. Okay, cushions them a little bit, right? All right, that is triglyceride. Next, we have this other guy, which is phospholipid. Phospholipids. Okay, and phospholipid has several components as well. Okay, we have our glycerol again. Okay, let's write that down first. Glycerol. We have the fatty acids, but this time we have 2 fatty acids. 2 fatty acids. And then we have this thing, which is the phosphate head group. Phosphate group, we'll just say. Phosphate. Okay, so this is a special molecule because the phosphate group has a negative charge, and it's going to make it hydrophilic. So we have a hydrophilic head, which means it loves water. And on the other side, we have these long hydrocarbon tails, right? And that's going to be hydrophobic. They will try to stay away from water. Okay, so this molecule is special because it has a hydrophilic part as well as a hydrophobic part. Okay, and as you will learn later on, the phospholipid is a key component, major component of the cell membrane. Okay, so usually we draw like this with the head and then the tail. Okay, so hydrophilic head and hydrophobic tail. Okay, so you will see that your cell membrane is arranged so that you have the hydrophilic head facing the water on the outside and on the inside of the cell, and then sandwiched between the heads would be the hydrophobic layer. And we'll talk more about that later on. Okay, next one. What is this thing? What is this thing? Anybody? With the 4 rings here. Anybody recognize this molecule? If I show you a picture of something with 4 rings and ask you, what is it? What would you choose? That is the steroid. Very good. Okay, steroid. So we have the fused ring here. Okay, that's the first component. 4 fused carbon rings. Okay, all these points on the shape, those are carbons. And we have a bunch of other stuff that you can add to it. Okay, so these are called functional group. Functional group. Okay, think of like, these are like accessories on your phone or something. Right? You can add different things to it. You can add like a, I don't know, like a case to it. You can add one of those little loop thingies, a lanyard, whatnot. So different accessory you add to it would give it different properties, give it extra functions, for example. Okay, so these are functional groups that you can add to the steroid, and that would create different types of steroids. Whenever people hear the word steroids, they think of like, you know, performance enhancing drugs, but that's not the only type of steroids. There are many other different types of steroids. And in fact, we do need natural steroids in the body because, for example, they make hormones. Okay, so hormones are these signaling molecules in the body, and that's how our body communicates, how the cells communicate with each other. And hormones can be lipids or they could be proteins. So examples of steroid hormones would be things like testosterone. Right, that's the male, the dominating male sex hormone. What about for females? What's the dominating sex hormones for females?
Estrogen.
Yeah, there's the estrogen. And one more? What's the other one? Sorry?
Progesterone.
That's right, progesterone. Very good. Okay, so these are steroid hormones, and we make them from cholesterol. Okay, so cholesterol is another steroid hormones. Okay, and some of the steroids they are also found in cell membrane. Okay, so major component being the phospholipids, and then we also have some of the cholesterol, you know, in the form of cholesterol. All right. There we go. Next, compare saturated and unsaturated fat by completing the table below. So fat is triglyceride, as I mentioned earlier, and then there are 2 types of fat. There's the saturated fat and there's the unsaturated fat. All right, which one is the healthier choice? If you have to chuck down some fat, would you rather do unsaturated fat or saturated fat? Which one would you rather have more of? Which means the healthier choice.
Unsaturated fat you'd want. I think you said in your PowerPoint that they banned saturated fat in 2018.
They banned trans fat. Yeah, trans fat. Yeah.
Trans fat.
Yeah. So unsaturated fat is the healthier choice. Okay. So what's the difference, anyways? Well, let's write them down. Okay. So for the saturated fat, the components, we have our glycerol. Okay. Plus 3 fatty acids. Okay. As for unsaturated fat, exactly the same thing. So what's the difference? Well, the difference is this. I'm gonna have to zoom in so I can fit in more stuff. I always have trouble allocating appropriate space for the worksheets. Okay, so the type of fats. Okay, so the type of fatty acids that you will find in saturated fats are going to be saturated fat. Saturated fat. Oh, I just see a comment in the chart room. When I had allergic reaction to something, they give me steroids. Yeah, steroids is can be found in medication, right? Cortisol. Your body make natural steroids called cortisol. It kind of suppress inflammation. So if you have allergy, you want to suppress the immune system. That's why it's steroids. If you have an acne, you put on steroids, right? That is also suppressing the inflammation. Okay, saturated fat. What does that mean? It means that the carbons in the fatty acids are bound to maximum number of hydrogens. Okay, there is no double bond, no double bond. Okay, and yeah, we'll leave it like that. Okay, whereas for the unsaturated fat, okay, you will have, what would you have? You will have at least one unsaturated fat in the fatty acid. Okay, so that means some of the carbons are not bound to max number of hydrogen. They have room for more hydrogen. Okay, and then there are going to be some double bond. Okay, and then there's going to be a kink in the structure. Okay, so what does it mean, right? Okay, I'll let you guys copy first. I think I might have went away too fast on that one. Sorry. Okay, copy it first and then I'll explain. So for the unsaturated fat, your carbon would have single bond, single bond, single bond, and then every now and then, if it's an unsaturated fat, you might have a double bond. Okay, so every time you have a double bond, right, it's going to create like a kink, a little bend in the tail, right? So if you imagine this is like your glycerol, and then you have for the unsaturated fat, you might have one fatty acid that's saturated, and then you might have another one that's not, and then it has all these kink in the tail, and because of all these kinky fatty acid tail, right, they're kind of sticking out all over the place. The molecules are not able to come together easily. Okay, and for that reason, at room temperature, they tend to be liquid. Okay, because they do not pack together easily, right? Due to the kinks. But if it's a saturated one, then the tails are straight, right? So the molecules can come very close together without getting into each other's way. So they pack easily, causing them to be solid at room temperature. Okay. So most of the saturated fat, they are derived from animals. Not always. There are some exceptions. But anybody have any examples for saturated fats?
Butter.
Butter, yeah. Lard, that's another one. Good. Butter, lard tastes so good when you use them to bake, but it's so bad for your body.
Would it be cheese?
Cheese is mostly protein. There's some fat in it, but that I don't think that would be an example. Jello is, believe it or not, sugar and protein. There's no fat in Jello. Margarine. Okay, margarine is an interesting one. Margarine is when you take unsaturated fat and you force it to take up hydrogen, okay? Because the carbon has room for more, right? So you put more hydrogen on it using a process called hydrogenation. Okay, hydrogenation, like that. Okay, and then it converts it into margarine. And you know that stuff that says like, can't believe it's not butter, right? That's how you made it. You start from an unsaturated fat, but then you chemically convert it into a solid state through hydrogenation. Yeah, ghee, that's correct. That's another one. And any plant oil that you know that's saturated. Some people like to cook with it. No?
Avocado oil or olive oil?
Avocado oil, olive oil, they will be liquid, right? So that would be unsaturated fat. Coconut oil is the one I'm thinking about, right? Okay. For the other ones over here, yeah, I already see a lot of examples. So canola oil, olive oil, avocado oil, right? All these stuff. Okay, so these are mostly derived from plants. Okay, yeah, and then a bunch of other examples in the chat. Very good. Moving on. Oh, that's it for oil, for lipids. Any questions for lipids before we move on to proteins? I think the protein is the more confusing one. But no questions. Everybody's happy. All right. If you're happy, then I'm happy. Proteins. Label the different parts of amino acids below and show how peptide bonds is formed between two amino acids. So amino acids, they are the monomers for proteins. Okay, monomers for proteins. There are 20 different types of amino acids. Okay? And they all look like this. They have a central carbon. Okay. And the stuff I'm going to tell you is important, okay? Make sure you listen carefully. I forgot if I mentioned this in the recordings, but I found a question on the quiz with this. So make sure you listen. Again, this is what an amino acid look like. Nobody's going to ask you to draw it, but you should know that there's a central carbon. There is this thing here on the left side. We have the NH3. We call this the amino group. Amino group. Okay. And on the other side, we have the acid part. Okay, and it has a name. Okay, this part is called the carboxyl group. Okay, which is essentially the acid. So that's why it's called the amino acid, because it has amino and then it has an acid group on it. Like these are functional groups, like things that you can attach to it, right? So all of them are going to look like this. And what distinguishes them, what makes one differ from the other is this R group here. This is called a side chain. Side chain. Okay, the side chains are going to be unique for each amino acid. Okay, there are 20 different amino acids, so all 20 of them would have a different side chain. Some of them are acidic, some of them are basic, some are positively charged, some are negatively charged, right? Many different properties. Okay. So what do we want to do? Is we will take one amino acid and we will connect it with another amino acid using dehydration synthesis. Okay. So you should know by now what that means. Okay? Dehydration synthesis means I'm going to remove an OH from one side, and then we're going to remove an H from the other. Okay, so this comes out, H and OH makes H2O, and then you're going to be able to form a new bond between the C and the N. So this is called a peptide bond. Okay. Remember earlier when we were talking about the glucose, I said the new bond has a name, but I never told you what it's called. So here, this new bond is called peptide bond. Okay. Each of them has a different name, but it's too much to learn them all. But in any case, this is the peptide bond. So I'm going to draw it out for you. Okay. You don't have to draw this out. You can just watch. I just want to make a simple point. So we have the NH, the amino group. We have the central carbon of the first amino acid. And then we have the side chain. I'm going to call this R1 for side chain number 1. And then we're going to have the C double bond O. Okay, we no longer have the OH. So this carbon will be connected directly to the end of the next one. Okay. Again, don't try to copy it. Just try to watch and understand what's going on. Okay, so you see that this peptide bond is basically right here, right? Connecting the two together. And then this would be like the amino acid number 1, amino acid 1, and then this would be amino acid number 2. Is there any question about what I did here? Okay. Now, I'm going to keep on doing this. And again, you don't have to copy. You can just watch. So what's going to happen is if I have another amino acid, I'm going to remove the OH. I'm going to remove the H from the other one. And that will allow me to form an other bond. Okay, this is R3 now, the third amino acid, right? C double bond O. And then I can connect another one, right? R4 now. And then this could keep on happening and happening, right? R5, C double bond O, so on and so forth, right? So the point I'm trying to make is this. Okay, take a look at here. You see this backbone, right? N double bond, NH, CH, C double bond O. And then NH, CH, C double bond O. NH, CH, C double bond O. This whole thing is just repeating itself over and over and over again, right? So this could go on for hundreds and hundreds of amino acids. Okay, so this yellow ribbon that I draw, this is called the peptide backbone. Okay, this does not change. It's just repeating units of, you know, NCC, 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 NCC. It goes on forever, right? What does change is the side chain. Okay. So that is the this whole thing is called a polypeptide. Polypeptide is the protein version of polysaccharide. Polysaccharide is long chain of sugar, right? So if you have a long chain of protein, of amino acids rather, that's a polypeptide. Are we together? Okay. Very good. Draw the peptide backbone. Oh, I just did that. Okay, it's over here, but it was supposed to go here. Okay, so I'm not going to do that again. Next one. Complete the table about protein. Okay, elements. Okay, so what do we have? We have C, H, O, nitrogen plus trace of sulfur. Okay, one of the amino acid, right? One of the amino acids, only one of them. Cysteine, that's the one, contains sulfur. Okay, cysteine, C-Y-S-T-I-N-E. Okay, that's the amino acid that has the sulfur. You know what? You don't have to know that. You just know that one of them is like that. Okay. Building blocks for proteins: 20 different amino acids. Okay. 8 of them are essential, meaning your body cannot make it, you have to consume it. Okay, so you have to obtain it through your diet. The other 12, your body can't make it. Biological functions. What do we need proteins for? A bunch of stuff. Okay, so we need them to make hormones. And remember, hormones are just signaling molecules, how your body communicates with, different parts, right? And some of them are lipid hormones like testosterone, estrogen. Some of them are protein hormones, so such as things like insulin. Does anybody know another hormone by any chance that is a protein hormone? Just throw it out there and see if anybody knows. Insulin is the one that helps you absorb sugar, right? If you don't make insulin or if you don't respond to insulin, you get diabetes, right? I'm just gonna put another one here for anyone who's interested. Oxytocin. Anybody know what oxytocins are?
Yeah, you release it when you're happy.
That is dopamine. I believe that's what you're thinking of. Oxytocin has a much more important function. Any mothers here? You probably would have heard of oxytocin. No? Yes, it well not produce milk, but it caused the milk to be released, okay, to come out, okay, and it also causes uterine contraction when you are giving birth, okay. So that is a protein hormone. Okay, you learn all about this.
Guys can also lactate as well too. So.
Really? That is the first time I've heard about it. It's
possible. I've heard, yeah. I don't know, but that's why I was just about to ask you to explain. Like, I don't know.
Something else for me to Google when I cannot sleep at night. I'll look into that. I've never heard about that one though. Adrenaline is actually not. But anyway, that's okay. I'm just showing you, some examples. You don't have to really know them. Okay. Next one. We have enzymes. Right, enzymes, they catalyze chemical reactions. They will speed up chemical reactions in the body, and we can also use it for fuel. Right, as I mentioned earlier, if you no longer have a reserve for lipids, you are going to break down some of the proteins. That's why when you're stressed out, when your body go into starvation mode. Your immune system goes down because you start to break down a lot of these proteins, which could be vital part of your immune system. Okay. Next one is it can provide structural support structures. Okay. So like your muscle is made up of proteins. Your hair, your finger, a lot of stuff is made up of proteins. Okay. So that's what they are. You guys are having a field day with that lactation thing in the chat box. I'm glad you guys are having fun. Next one. Okay, complete the table about the structural levels of proteins. The first one is already done for you. Okay, so when we talk about how proteins fold together, we have different levels of structure. Okay, starting at the primary level, secondary, and we move up from there. So let's just review what those actually means. Okay, so the primary sequence is basically talking about the order at which we connect the amino acids together. Okay, so there are like 20 amino acids, right? So if I look at a long chain of proteins, right, there is maybe like the first one is glycine, and then aspartic acid, and then you have another one here, glutamic acid. Why is the color not changing? Glutamic acid, and then a bunch of other ones, phenylalanine, whatever the case is. Okay, so and then it could be repeating as well, right? So if I read the color is not changing. If you read the order of amino acid from one end to another end, that particular sequence is going to be called the primary sequence. Okay, and the primary sequence is going to be encoded within DNA. Okay, so your genetic information tells you what amino acid should be linked together when you make the proteins. And of course, what connects them together is the peptide bonds, right? Peptide bonds. Illustration, what does it look like? Well, it's just going to be, like a long chain of these things, right? Linked together. Okay. Next one. Secondary is talking about the formation of alpha helix and beta sheets. Okay, beta sheets. So what is the bonding characteristics? In other words, what holds these sheets together? Okay, it is hydrogen bonds. Hydrogen bonds. Okay, so I'm just going to go back here for a second. Again, you don't have to copy this. I'm just trying to explain to you. Okay, remember in the water molecule, I told you like the oxygen is going to be slightly negative and the hydrogen is slightly positive. So supposedly, if you follow the backbone, right, and then here is another parts of the backbone, and then the hydrogen here is slightly positive, oxygen here is slightly negative, then they can form a little bit of a hydrogen bond here, right? And all these hydrogen bonds, right, could help stabilize the backbone structure. Okay, so if you think about a helix, right, like this helical structure that I was talking about, like this helix, right? What holds it together? It's basically the, all these hydrogen bonds that you get. Okay. So back to the chart. Where am I? Hydrogen bonds formed in the backbone. Backbone. Okay. And illustration, what does it look like? Well, this chain is going to form into the helix, okay, and maybe the zigzag plata sheets. Okay. These are just like chicken scratch diagram, right? Like for like professional diagrams, please look at the PowerPoints slides. Next, we have the tertiary, right? The tertiary structure is basically the overall three-dimensional shape. We have a name for that. It is called conformation. Conformation. Okay, and what holds them together, the bonding characteristics, it is going to be the interaction between the side chains. Interaction between the side chains. So the R groups, right? Remember, I said some are acidic, some are basic, and then they could interact with each other and reinforce the overall 3D shapes. Okay, so to draw it, maybe it's going to fold back on itself, right? And then you're going to get like a three-dimensional protein like that. And many proteins will stop at tertiary level. They will stop forming like further complicated structures. But sometimes they will have an additional layer of structure called a quaternary structure. Okay, so that is when two or more polypeptides come together to form a complex. Okay, so to hold them together, it would be the interactions, between the polypeptide. Okay, so hemoglobin is an example. Okay, like you would have two, alpha subunit, that's what they're called, and then you would have two like beta subunit. So each of these subunits have its own function, but when they come together to form a complex, then you would have a functional protein. So hemoglobin. For those of you who do not no hemoglobin. It is the molecule that transport oxygen in your system. Okay, any questions? See that you guys type a lot of random stuff in the chat. Any questions about the proteins before we do some more polls? Okay, polling time. We don't have a lot of time, so let's just do the more complicated ones. This one, you will know the answer if you have been with us. Let's see. Okay, a couple more seconds just to log in a few more responses. Okay, well, the correct answer is carboxyl and amino group. You go back to here, you can see that, right? You take the carboxyl group and the amino group, you remove a water molecule, and that's how you form the peptide bond. There's nothing to do with the side chain. Side chains do not link together ever. Okay. Here is another question. This one should be straightforward, but we don't have time for it. I'm just gonna read it to you. It's talking about hemoglobin, and it has multiple things coming together, right? That would be the quaternary structure. Okay, let's try another one. This one is worth doing. Go ahead. Okay, we have two very popular choices going neck to neck right now. Please put in your answer, and we'll take it up in a bit. All right, close it in 3, 2, 1. Okay, well, pancreatic cell makes insulin, which is a type of protein. That is the key word here, a type of protein. These cells use something in order to make insulin. Well, if insulin is a type of protein, then we're gonna have to use amino acids, right? Amino acids. We're not gonna use fatty acids or glycerol because that's not what proteins are made up of, right? It's interesting because my other class, a lot of people also choose B as the answers. Anybody want to, like, for those of you who chose B, would you like to tell me why you chose that so I understand where the misunderstanding is? Maybe help you clear it up. If not, that's okay. Okay, so the answer is E. All right. Okay, in the last couple minutes, let's go through the nucleic acid. Okay, so complete the table about nucleic acid. So the elements are all the major ones. Okay, so there's C, H, N, O, as well as phosphorus. Okay, are you gonna talk about the quiz? Yeah, I will. Don't worry. Okay, we have time. We have like maybe like, you guys don't have another class afterwards, right? So yeah, hang in tight there. Building blocks. Building blocks is nucleotide. Nucleotide. Okay. So the function of the nucleic acid is it contains genetic information. Okay, such as instruction to make proteins. Okay. So here is a nucleotide, and it has three major parts to it. There is the phosphate group. There is the sugar. And we have a nitrogen base. Nitrogen base. Okay, so that's one nucleotide. Now the nucleotide comes in different forms, right? It could be A, C, G, T for DNA, and then H, G, C, U for RNA. And we can actually separate the nitrogen base as either purines or pyrimidines. Okay, so pyrimidines are these three. Okay, cytosine, thymine, and uracil. These are pyrimidine, and they have a single ring in their structure, one ring. Okay, whereas the purines, these are the purines, they will have two rings in it. Purines. Okay, two rings in their structure. So in terms of pairing rule goes, the purines will always pair with the pyrimidine. Okay, so A goes with T or U, and then C pairs with G. Okay, so to help you remember, you can remember the phrase pure as gold. Okay, so purines are A and G. Okay, the other ones, they are pyrimidines. Okay, let's compare DNA and RNA together. So the nucleotides here, we have the phosphate plus a deoxyribose. Ribose is a 5-carbon sugar, and this one is missing an oxygen. That's why it's called deoxyribose, plus a nitrogen base. And the base for DNA could be A, C, G, or T. The structure is a double helix. Right? It is complementary. That means if you know one side, you will know the other side. And it's also anti-parallel. Okay. Which means they're parallel to each other, but they run in opposite direction. Okay. And for RNA, it is the same thing. We will have the phosphate. This time we have a ribose sugar. So it's not missing an oxygen, nitrogen base. Instead of thymine, you would have A, C, G, and U. And it is a single strand. Okay. I spelled complementary wrong here. It should be E. Complementary. Okay, that means if you know one side, you can predict what's on the other side. Okay. Now, unfortunately, we don't have time for the long answer question, but that's okay. I'm gonna post the answer for the long answer questions, and we will take up the application question next class because the quiz does not have any application question. Right. So let me pull up the quiz information. It's posted online already. Anyways, you guys need to check the eCentennial regularly, so you know when things are happening. Let me see where this is. Okay. Screen number 1. So there it is. If you go log on to the course homepage, you will find the quiz information. Okay, so it's going to be available on Tuesday. Oh boy, I totally forgot to change the date. That is going to be January. What is next Tuesday? Next Tuesday is 25th. Yeah, January 25th. Available from 6 to midnight. That means you can start anytime during that window, and it's going to be 45 minutes. It's the first quiz, so I will keep it simple. 20 standard multiple choice questions, 5 multi-select, which means there are more than one correct answer, 2 marks each, and no application questions yet. Okay, we'll have it on the test or quiz 2 later on. 10% of your final grade. If you need accommodation, please email me your documentations. Okay, and that is it. Okay, so for the long answer questions, I will post the answers online afterwards. And you can take a look at it. If you don't understand something or you need clarification or extra help, please feel free to contact me. Otherwise, have a good weekend, and I will see you next Thursday for lecture 3. Okay, bye for now.